Hello, I'm Petra from MTC, and in this video we use Spaceclaim or Novamethod to cut a part to manufacture with laser cutting and 3D printing combined. So firstly, create the cutting tool by pulling a surface body that will slice the thickness of the plywood sheets. I use 22mm boards. And then pattern to have the height you need to cover your part. Then combine all surfaces into one surface body because the combine tool cuts with one body. I will rename this part Z Cutter 22mm. Now moving on to the part. Firstly, shell your part, the minimum thickness you want the 3D printed walls to be. I use 8mm for FDM technology. From there, create an inner volume with the core tool, or otherwise the volume tool. It's good practice to rename your solids and to also place them on specific layers so that you have more control over the two part types. Okay, our next step will be to slice the wooden inner. Now hide the shell and insert the Z Cutter 22mm. Position the cutter to be collinear to the bottom surface of the inner. Once positioned, use the combine tool. Cut the inner into 22mm thick layers in one go, ending up with 12 solids. The next step is to select the top surface of each layer and copy and paste it to use for cutting. Now select all the surfaces simultaneously and pull with the cut option highlighted to remove all the material that will be laser cut and leave us with the inner step profile for our 3D printed shell. These steps we want combined with our 8mm shell so that there would be no spaces between our laser cut parts and our 3D printed shell. I'm just pasting the surfaces again for later use, that's still on my clipboard. Now turn on your shell and combine your shell with the steps we just created. Now this is the representation of your 3D printed part. I'm renaming the solid to stepped shell before creating more solids with the surfaces. You can either export the surfaces and use them to laser cut your parts with, but for a bill of material you might need solids to represent your laser cut parts. So I'm going to use the surfaces and create the parts. By using the no merge function and selecting all surfaces simultaneously, I pull them to a 22mm thickness to create my solids. Select, right-click, and move each to new component so that you have a proper bill of materials. Then from here, to have a proper fit into the FDM part, I'm going to offset my profile surfaces 0.5mm. I don't have to activate each part before modifying it, even though it's solids of different components. I just double click the surface and then pull. If you do run into some errors, just try selecting from a different angle. Many times it's just the way the software calculates. Over here I do run into some geometry problems created by our pool of the surfaces. But with Spaceclaim and Novamethod, it's quite easy to just fill it or defeature it and just pull the radius again up to the closest radius available. No need to go back to your cutting profile or do anything over from scratch. With the geometry fixed like that, it pulls without a problem, and I can offset the rest of my layer 0.5 mil. I use my section view to double check that all my layers has been offset correctly on both sides. Now we can carry on slicing the shell to fit the print bed of the 3D printer. I created a slicing tool the same way I created the Z cutter, but I spaced it 250 mils apart and then copied and rotated to have an X cutter and a Z cutter spaced 250 mil. Okay, I start by positioning the cutter to the center of the part. But then I realize it's going to cut quite small slithers at the far ends of the part. So I moved it a bit off center to just have 3 slices instead of 4 and not having too thin slithers in the sides. Now using the combine tool once again, use your X surface and your Y surface to cut the shell into pieces that will fit your print bed. If you prefer using dovetails to put your 3D printed parts together, then design the dovetails into your X and Y surfaces. Now you have all your parts for laser cutting and those for 3D printing. A final tip to ease assembly is to cut a locating hole through your laser cut parts. A square hole that you can position over a square tube would place your laser cut parts in such a way that it would be aligned for assembly, and then you can assemble your 3D printed part over your laser cut parts. I hope you found this video informative. For any more information on Spaceclaim, Novamethod or 3D printing for manufacturing, visit us at www.simulasi.co.za. Or Novamethod